Okay, in this video, we want to start working some problems involving surfaces of revolution and how to find their volumes. And here we have the curve x squared plus 5 equals y, and we're taking a segment of the curve going from x equals 1 to x equals 3. So let's just take a minute here and try and get a rough sketch of what that curve might look like. Here's y-axis, here's the x-axis. X goes from 1 to 3. When x is 1, y is going to be 6. We're not going to draw this to scale. And when x is 3, y will be equal to 14. And if this wasn't here, it would be a parabola. So we know it's going to have a parabolic shape. So it looks something like this. That would be our curve going from x equal 1 to x equal 3, y equals 6 to y equals 14. And let's say we're going to rotate this curve about the y-axis. And we want to know what will be the volume that is generated. And the answer to that question is, let's move our 3 over a little ways. As to determining the volume, that determines upon whether we use the disk method or the shell method when we set up our integral. If we set it up with the shell method, remember then we're forming strips that are parallel to the axis of rotation. So if we're going to use the shell method, then we're forming strips like this, vertical strips, starting at x equal 1 and continuing on out to x equals 3. So if we're using the method of shells, this is the region here being rotated about the y-axis to generate the three-dimensional figure. On the other hand, if we use the method of disks, when we're rotating about the y-axis, and we have the same curve here, like this, 1, 3, 6, and 14. Now if we're using the method of disks, remember how we had it set up in our introductory videos when we're rotating about the y-axis. And if you haven't looked at those introductory videos, I think you'll find it worthwhile. Now, if we're doing rotation with the y-axis and we're using the disk method, now we're drawing horizontal strips like this, starting at y equals 6 and continuing on to y equals 14. So if we're considering the disk method, this here would be the shell method, and we're dealing with shells. This is the disk method. And with the disk method, it's this region that we're concerned with. And that's the region now that's going to be rotated about the y-axis to give us our three-dimensional figure. So when you're solving problems, think it through carefully exactly what they're asking you. If you're setting it up like this, and you want to know what is the volume of the region underneath the curve from x equals 1 to x equals 3, then obviously we're going to be using shells. On the other hand, if we have this curve right here, and we're rotating it about the y-axis, and they're concerned about the region from y equals 6 to y equals 14, then that's this section here, and we have to use the method of disks. Okay, let's say then that the problem is stated so that they want to find the volume underneath the curve from x equals 1 to x equals 3. So now we're using the method of shells, and the formula is, which we derived in our introductory videos, 2 pi, the integral of x times y dx, x goes from 1 to 3, and y has to be expressed now as a function of x, which it is, no problem. So here then, the volume will equal, and we're just going to set this up, we're not going to take it all the way through, will equal the integral x goes from 1 to 3 of x times y, and y is this, x squared plus 5 dx. And again, like I say, we won't take it all the way through and do the computations. As you can see, it's a pretty straightforward integral here. It's going to come out being, once we multiply through and integrate, we have 2 pi times 1/4 x to the 4th plus 5 halves x squared, and x goes from 1 to 3. Plug those values in, and it comes out the volume is equal to 80 times pi. And again, we're not going to go through other steps because this is a pretty simple integral to deal with. What we did want to talk about were the two different techniques involved and how they involve different sections here of the curve that we set up. And again, the problem states find the volume underneath the curve from x equals 1 to x equals 3. You're going to use shells, and that's our formula right there. Now, let's say, Daniel, that we had this problem. Clean this up just a little bit. So now we're going to be using disks. So now the volume integral is, and again, we explained all this in our introductory videos. Hope you've had a chance to look at them. Now for this one, the volume integral equals pi times the integral of x squared times dy, and y goes from 6 to 14. And we're integrating with respect to dy, so x squared has to be expressed in terms of the variable y. Well, that's real easy. X squared will equal y minus 5. So this will equal the integral of y minus 5 dy. Y goes from 6 to 14. And again, the integral is very easy to handle. It's almost trivial. We have, it comes out being equal to pi times 1/2 y squared minus 5 times y, and y goes from 6 to 14. You plug your values in and do the number crunching here, and this time the volume comes out equal to 40 times pi. So that's it for this video. We just wanted, since we took so much time to show how we can set up in our introductory videos how to solve problems, whether you're revolving around the x-axis or the y-axis, and how we develop our formulas, our volume integral formulas for the shell method and the disk method. We wanted to apply it to a problem, but also in this problem we wanted to stress that when you're going to set up the volume integral, are you going to set up as a shell volume integral or a disk volume integral? And that depends upon the way the problem is set up. So watch out for that. Now, what we're going to do in the next video, before we solve different types of problems, we're going to consider the same curve and we're going to rotate it about the x-axis, and then we're going to find corresponding volumes depending upon whether we use the shell method or the disk method. So again, we have a chance to compare and contrast those two. So come back and join us for that video, and we'll take it from there.